Okay, so welcome to this video where we are going to solve a question based on kinematics. It says a person is running at his maximum speed of 4 meters per second square to catch a train. When he is 6 meters away from the door of the train, it starts moving at a constant acceleration of 1 meter per second square. How long does he take to catch the train? Alright, so if we check the question, we are going to understand that there are certain key factors that are so important over the question. So in this case, we critically look at it, we are going to find that they're saying when he is 6 meters from the door of the train, it starts moving at a constant acceleration of 1 meter per second square. Okay, again, if we check, we also have to know what maximum speed is. Whenever they say maximum speed, they simply mean he was moving with a constant speed of 4 meters per second square. So in initial and final, they're almost the same. Now the trick part is, since he was almost trying to catch the train, what we are going to do, we need to understand that the distance, which is 6 meters, is the one that was the initial distance of the train that it already covered. So this 6 meters which is here is supposed to be our initial distance covered by the train already. Okay, now let me try to remove this page so that we can try to solve the question. Okay, so to easily illustrate what is happening, physics is all about sketching. So here I'll sketch the sketch of the two motions. Okay, so since the boy was moving with a constant speed, meaning that his speed is going to start from the position where he won't be changing its speed. It has to start from here, just moving like that, to show that it was a constant speed without even changing. But for the train, it started from rest, so it will start from this given point, accelerating until it will start accelerating, and then it will start moving in the same direction with the boy. It will start accelerating from 0, meaning that its initial velocity has to be equal to what? Has to be equal to 0. But what we are going to understand the most is, since initial velocity is equal to 0 due to the fact that it started from rest, it had the initial, or rather it had the acceleration of 1 meter per second square. Now here there is a critical thing which we have to focus on. Here we have to understand to say it was initially 6 meters away from where? From the boy. So we are going to have this type of emotion, which is a motion in the x-axis. Okay, so the distance, it has to be given by this, and this has to be the formula we're going to be using. So here I'll say 1/2a(t) square as the expression. This is the expression we are going to be dealing with. So since we are dealing with the motion in x, meaning that where there is s, I'll have to do what? I'll have to separate them like that. So this is going to be the distance covered by the person, p, and the distance covered by the train. And that has to be the thing we are going to be dealing with to say the motion in x. So we are going to have two motions here. Okay, we are going to have two motions. The first motion is going to be, let me start from here. The first motion is going to be the motion of the train, whereby since it had the initial velocity, initial displacement of 6, I'll say equal to. So since we don't have the initial velocity, it started from rest, it won't have the initial velocity at this moment of time, cancelling that entire part, and we are going to have the last thing, which is here, which is found somewhere there. All right, and I'll write it like this. I'll say 1/2a(t) square as the expression of, so that one is giving us 0 because initially it was starting from rest. So initial velocity has to be considered to be 0. All right, so since the person was moving with the constant velocity, it is also going to give us a certain expression for the guy that was moving towards the train. Okay, so his initial velocity is going to be the same as the final velocity. So since in the expression which is here we don't have the final velocity, definitely we won't use another expression. Where there is the v initial, we are going to replace with the we're going to replace with the same thing. Okay, so if we critically check, we need to understand to say this expression is going to be x has to be equal to, so this can go to my right hand side. I'll say 6 plus, all right, 1 over 2. So since this one is given already in the question, they're saying 1, you multiply this one by 1 and it will give us what? Our half. This has to be the expression for the motion of the train, and it has to be the first expression. So we come to the motion of the person that had the constant or rather maximum speed. So here, since he was moving with the constant speed or rather maximum speed, meaning that we won't have what? Acceleration. So we can just get this to be our what? Our initial, and he was moving in that given direction. So we are going to write another expression for what? For the guy now, whereby he was moving with a maximum, he reached a maximum speed, meaning that acceleration is going to be equal to 0 because velocity was what? Was constant. So I'll say the motion of the person, I'll say xp, and this can be xt equal to, so we're going to deal with this. We have 4. Okay, I'll multiply 4 by t, just like that. So since this one was a constant speed, meaning that acceleration has to be 0, and it is going to cancel out everything which is found on that other part. Okay, so again, this also qualifies to be the second expression for the motion of the person. So this and that, they're going to interlink. Why? Because for two particles to collide, meaning that for them to catch up with each other, meaning that they had covered the same what? Distance. The distance that is going to be covered by the person has to be equal to the distance which is going to be covered by the train. That's why that's when we can easily find the time they're going to have. That's when we can easily find the time we're going to have. So the expression for the person, I'll replace it with 4t, say 4t, just to be equal to the expression for the train. I'll get what I'm having somewhere there, which is 6 plus 1 over 2 t square. Okay, so what are we supposed to do for us to get rid of the half which is found on the part of t square? What are we supposed to do? So I can first of all get rid of 2 by multiplying throughout by what? By 2. Okay, so if we say 2 multiplied by 1 over 2 t square, we are going to get t square. Okay, because 2 and 2, they are going to be cancelled. If we say 2 multiplied by 6, we're going to get 12. And whenever we say 2 multiplied by 40, we are going to get what? 8 t square. Sorry. Okay, so we can make this move to my right hand side. I'll make 8t to move to my right hand side so that we can come up with a single expression. We're going to have t square plus 12 minus 8t. Okay, so remember, since we've removed 8t from the left hand side, we are going to equate everything to 0. Okay, so definitely this one, it has brought us to a simple factorization. We can factorize this by first finding certain things. So I'll say t minus 8t plus 12 is equal to 0, right? Okay, so here we need to find what we call the product sum factor. So I'll say product has to be equal to 12, sum has to be equal to -8, and factors will be -2, -6. Meaning that whenever I add -2 and -6, I'll get -8. I multiply them, I'm going to get what? I'm going to get 12. Alright, so we can proceed. Where there is -8t, I'll replace with -2 and -6 in that same expression that we have. Okay, somewhere there, I will just replace with these two. So we're going to have t square minus 2t minus 6t plus 12 equal to 0. Okay, so we're going to factorize the first part. Say t open t minus 2 minus 6 open t minus 2. Okay, so I'll say t minus 6 inside the brackets, and then t minus 2 equal to 0. Okay, so this means that t is going to be equal to 6 seconds. Another t is going to be equal to, it has to be equal to the other answer, which is 2 seconds. All right, so these are the two answers. Now we have to be careful whenever we want to choose the correct answer. We can't pick the answer which is ahead of the other, meaning that we are doing nothing. So we are going to focus on the first answer, because for them to catch up with one another, meaning that they are going to encounter this the first time which is going to be covered. We understand we have 2 times here, but we need to focus on the time which is going to be first encountered. In this case, we simply mean 2, which is found somewhere there. In this case, we mean 2, which is found somewhere there, and it is going to be our correct answer. It is going to be our correct answer. So 2 has to be our answer, like I'm from explaining. It has to be our answer, I repeat. All right. 6 can't be considered to be our correct answer. Okay, so 2 is going to be our answer. Let me repeat that. 6 can't be considered to be our correct answer because it is ahead of what? Ahead of 2. It is ahead of 2. Okay, as simple as that. Okay, so to easily prove to say if they're going to cover the same displacement, like I said, you get this 2 which is here. You can try to prove by placing it in either of the equation. You start with this one, the distance covered by this, and the distance covered by the train. If you put this same 2 where there is t in that expression, you find that it will give you a certain answer. If you get this one, you get this, you place where there is that, we are going to get a certain answer. And also if we get this, we'll place where there is t square, we are going to get the same answer as what we are from getting in that other expression. So the thing is, yeah, if we say 2 square, we are going to get 4. 4 multiplied by half, we're going to get what? 2 plus 6, we're going to get 8, and it has to be a similar answer as compared to what we got. So this qualifies to be our correct answer for this entire question. Thank you for your time. Thank you for watching.